Hello and welcome to all. My name is Julien Caudroy. I'm Vice President Communication, Marketing and Event for Innovitech. As many of you know, we created a few months back AIxSPACE with Euroconsult. AIxSPACE is the first event fully dedicated to AI applied to space. As artificial intelligence is redefining the frontier of the space industry and radically transforming the sector, our objective was to bring together key stakeholders in both space and artificial intelligence industry and allow everyone to obtain concrete information, contacts, and business opportunity on this new combined industry. If it had not been for such a particular context, AIxSPACE would have been held today. With that in mind, and while we are patiently wait for our postponed event, it is a great pleasure that we offer to all of you today this sneak peek, a webinar with 4 incredible leaders of their respective industry, a taste of what you can expect during the actual event. A bit of an update as well. In order to minimize any additional risk, we have decided to postpone the event not to November the 2nd, but to a new date to ensure the quality of the event and to guarantee the safety of our participants, speakers, and teams. With that in mind, AIxSPACE will be postponed to January 18, 2021. I hope, of course, to have the pleasure to meet a lot of you at this event. Now, without any more delay, I will introduce our speakers. So from Montreal, first of all, Isabelle Tremblay, Director, Astronaut, Life Science and Space Medicine of the Canadian Space Agency. From Waterloo, Ontario, we do have with us Joel Cumming, CTO of Skywatch Space Application. From Brampton, Ontario now, Mike Greenley, CEO of MDM. Hi, Mike. And the last one, Philippe Beaudoin from Montreal too, Senior Vice President and co-founder of Element AI. And now I will pass the mic to Martin de Reuter, Managing Director of Euroconsult Canada, and let's start the conversation with our guest. Enjoy.
Thank you, Julien, and thank you, the full Innovitech team for hosting this webinar. As you mentioned in the introduction, I think we have a great lineup of speakers to kind of achieve our objective of today, to go beyond the buzz. AI in space is obviously a fascinating topic, and if you look back, there's quite a bit of interesting history too, because if you think about it, long before artificial intelligence has become this kind of major trend, technology trend impacting kind of a lot of industry, practically the world, Hollywood provided us this first examples of artificial intelligence with some number of space movies. So I think probably all of you are familiar with HAL 3000 in Space Odyssey, or my personal favorite R2-D2 from Star Wars, which kind of indicates that there's probably some kind of perfect match between space and AI. Of course, you know, those examples are more like science fiction, but we have seen an increasing adoption nowadays of AI in across different layers of the space segment of the space sector. So with that, it kind of leads into my first kind of question for each of the panelists. What are kind of the real case examples today that you see and where you're most excited about when you see AI place in the space segment? So I will first start with Isabelle. Maybe you can give us your first views on that. Just one housekeeping point. We'll have about 45 Q&A and as well 50 minutes reserved for Q&A from the audience. So if you want to submit your questions, please use the Q&A section for that. And at the end of the last 15 minutes of the webinar, we'll sure to address as many questions as I can. But first, back to you, Isabelle, about some first real case examples. Go ahead.
Yes, absolutely. So I'm going to speak mainly today about my perspective as Director of Astronauts, Life Sciences and Space Medicine. We're currently considering future applications of AI for healthcare. This will be especially important for deep space missions to Mars. They will last 2 to 3 years. The crews will be very remote. There won't be any possibility to evacuate them. long communication delays up to 42 minutes round trip, or around 40 minutes round trip. And we're envisioning applications of AI in this context, both to support operations, but also to make sure that the crew can take charge of their own health and that they can be autonomous and self-reliant for that very long mission of 2 to 3 years. Currently, there are so many applications of AI in healthcare already. It is starting, I would say, but it is really advancing very quickly. Applications like diagnosis, we hear about looking at images, looking at a lot of data, large amounts of data to improve diagnosis. So we know many applications in radiology, to detect cancers earlier and things like that, so to diagnose conditions earlier. Many applications also in developing new medicine, in treating rare diseases, for example, in streaming patient experience, so more applications that are more into the operations of the healthcare systems. Lots of applications also are emerging for health trending. So looking at predicting any health conditions. So it's a more preventative approach. And when we look at the future of healthcare in space, there are many parallels we can do with the future of healthcare on Earth. And this is really where we want to work, at the convergence of space and terrestrial needs. For example, we see approaches that are point of care. So we bring healthcare to where the patients are. We want to empower the patients, so enable the patients to take care of their own health. And that's what we want to do with crews on deep space missions. We want approaches that are more preventative, predictive. We want also approaches that are more personalized, that are more targeted to specific individuals. And this is what we're looking into. But in space, really, we're creating the future. So all those applications are in the future. They don't exist yet. Mm-hmm. And it's one of the most important problem in deep space exploration, is how we're going to keep our astronauts healthy on deep space missions.
Right. Very good. Very interesting. Yeah, we'll talk definitely more about the future and what are the objectives they want to obtain and how we should get there. But I would like to give the other speakers as well some opportunities to provide some real case examples. So Mike, at MDA, obviously you work on a wide domain of space activities. So maybe you could give us some of the kind of examples where AI is applied, and maybe also what is helpful to be understanding what kind of impact it has. Does it improve operational efficiency? What kind of benefits do you get from applying AI?
Sure. Can you hear me okay?
Yes, I do.
Okay, great. Yeah, as you say, MDA works in a broad range of activities across space. I think a couple of the areas where we're seeing AI being used more and more, either in development all the way up to operational systems, would be in the Earth observation business, in the robotics, space exploration side of things. And then we have a few projects that Isabelle was just talking about, where we're looking at health monitoring sensors for the human body, and starting to look at frameworks for using that information to diagnose or predict an individual's health. In the Earth observation side of things, we would see artificial intelligence starting to be developed into solutions for the TC-PED cycle for planning Earth observation activity, for sure, in terms of being able to look at planning of satellite operations. In addition to, once we're getting data and information, a wide range of analysis of the information that we're getting from Earth observation satellites. So change detection for using algorithms to be able to do forestry analysis, or be able to do ice analysis from Earth. In addition to enhancements to be able to analyze and then quickly, rapidly disseminate that. In addition to be able to starting to work towards cross-queuing of Earth observation activities in the searching behavior. In addition to the Earth observation satellites, we would also be using AI in Earth observation in non-satellites, things like unmanned aerial vehicles, full motion video, using them to detect targets in that type of an environment. In the robotics side of the house, we see artificial intelligence being used to continually automate robotic operations. In these areas, We've transitioned over the decades from robotic operations where an operator would be at the control of a joystick to increasingly scripting and aggregating commands into higher level, more abstract commands, in more even goal-based commands now into the future. In these areas, we're starting to see a number of complex commands being simplified into higher order goals that we can give robotics and then have the system be able to execute a series of steps, still in collaboration with humans and still safely, towards a future of operations out by the moon, where we would expect to have much higher levels of goal-based behavior in our instruction sets to robotics, 400,000 kilometers away.
Very good. So quite a number of examples there. Joel, maybe I can turn it over to you, and could be actually interesting to maybe highlight a bit about the value proposition of Skywatch, which is one of kind of these new emerging players from Canada. So we're all pretty excited to see what your plans are, and as well how AI basically helps to deliver basically your value proposition.
Sure, absolutely, Nathan, thanks. Yeah, so if you're not familiar with Skywatch, we've built an API that aggregates the world's satellite data. And for those who aren't familiar with Earth observation data, there's sort of this belief or assumption that it's easy to get data from satellites. There's lots of them covering the Earth all the time, and that data can just flow. But for those in the industry, we know that it's actually very challenging. Historically, the sales cycles have involved phone calls and order forms that go to satellite companies. Historically, satellite companies and operators have sold to government and big business. But really, to enable data to flow to application developers who can leverage this en masse, that's a very hard problem to solve. And so that's where Skywatch has positioned ourselves, where we're aggregating the world's satellite data, making one API that delivers the data in the same format in a simple way at a very low cost that can enable this machine-to-machine capability between the collection all the way down to the consumption. And so AI for us, we don't get into a lot of the fancy things that Phil or Mike have talked about with some of the overall analysis. We think about AI in terms of pragmatic AI. So really simple value-driven functions in an environment that can remove humans from decision-making to optimize the delivery of that data. So whenever we can move humans out of the loop, that means the data can flow faster from the sensor down to the application. So in terms of some examples of what we built a couple of computer vision models. They can look at things like image quality. They can look at things like classifying, pieces of the image like clouds. So you can imagine if a sensor is delivering data to an application, you don't have time for a human to inspect that to be able to ensure quality. So we built a couple of models that way that are very useful for us. And the other area we see is very interesting in the future, and Mike alluded to this with planning of satellite operations. So, typically what happens if you're not familiar with satellite operations, and I wasn't before I started this role, a bunch of orders are collected, and every day a group sits down and decides, what are we going to go out and capture that day? And so that's a combination problem that has to be solved. But step back and think, now if you have thousands and thousands of applications all requesting data, into an aggregation layer, now you can start to actually optimize space assets. So if you look at an organization like the Canadian Space Agency, who recently launched the RadarSat Constellation mission, if we could optimize and say, hey, in fact, there are going to be other captures either by commercial providers or by other open satellites, open data satellites out there, and we don't need to spend the expenses of capturing with RCM, where we can capture in other places. There's a huge cost savings that can come from optimizing the macro problem here altogether.
Very good, interesting. And in terms of the percentage, let's say you talk about a lot about automation, right? So, I mean, it's a kind of a process where you lead to two. So how much % would you say is now kind of fully automated in the process, or and still needs some human kind of touch?
I mean, we aspire to, it really depends on our data partners. Some of them are more sophisticated than others. Some of them, there's a little bit of Wizard of Oz going on with the curtain and some magic, some human magic behind the scenes. But certainly the value proposition's there, and it's working through a lot of the legacy systems that just need to be integrated with or replaced. And those are big opportunities on both sides.
Certainly. Good. Philippe, let me then turn it to you. So obviously you're not only active in the space sector, right? Element AI is touching many other sectors, but maybe can you give us some examples of some of the work that Element AI has done for the space sector in particular?
Sure. Just maybe for completeness, a bit of a word about us at Element AI and what we do. I guess the way to describe it is AI is difficult. AI is new. It's hard to turn into something real. So we help our customers what we call operationalizing AI. So making sure that what goes on in the lab can be translated into something that works in a real situation with the real data they have access to. And yeah, basically just make AI real for our customers. We do that through an array of products, services, and tools that we can deploy to build the solutions with our customers. And so to go back to your original question, where have we been using AI in space-related projects? So one of our very interesting results is also in the area of Earth observation. Earth observation data is easy to get at the low resolution, but it's hard to get at the high resolution. And sometimes the high resolution version is where the interesting detail is going to be. So what we've managed to do is when you have multiple images of the same area from multiple scans of an Earth observation sensor, we can combine all of these images together and get a higher resolution image. We do that using AI. And here I want to maybe double click on this AI thing a little bit. You know, you talked about R2-D2 and C3PO, and we see robots, we see like personal assistants when we talk about AI. But the view I'd like to take here when we're thinking about these recent advances is the view of AI as machine learning, because really that's what has changed in the recent years. It's the fact that we are able to train machines using data in a way that's much more efficient than it used to be, that's able to capture much more abstract details than what we used to be able to do. And so this machine learning that we deploy to get this, what we call multi-image super resolution challenge. And so we developed one of the best in the world technology or machine learning based algorithm to do this. Now there are other aspects that we work on. We work on robotics and a bunch of things that are related to or could be related to the space sector. But there is one that I think is maybe a bit more remote, but potentially even more impactful. And it's using AI and machine learning to help with the manufacturing process, which we know is very particular in the space industry because it's, you know, smaller volumes, more, you know, more unique manufacturing challenges. And what we've built is a product called Knowledge Scout that's really good at helping capture details about manufacturing process, even if these details are just in natural language form, right? Or it's just like, here's an example of a situation that went wrong. And to capture them and disseminate them, these details throughout your company, but throughout also some of your partners. So this is, I believe that the advances in machine learning are going to have a huge impact on the manufacturing process itself, especially in situations that are common for the space sector.
Very interesting, and actually a perfect segue into my second question. And before we will dive into it, I'm launching the kind of panel. Well, it's actually an audience polling, so they could basically everybody can vote as well, and I hope you will see it live. So I think what you already referred to, Philippe, is like kind of the impact artificial intelligence or machine learning can have, and there are different kind of parts in this, let's say, satellite domain that can have an impact too. So including satellite manufacturing, operations, EO, data analytics, space exploration, satellite communication. So I would ask everybody to vote for where they think artificial intelligence can make the biggest impact. So maybe, and I also maybe want to give Mike the opportunity as well. So first, Mike, maybe you have I know you touched on basically all of these segments within MDA. So I'm not sure you have a favorite or where you think, for the company, this can have the biggest impact, but otherwise maybe as well, first to follow up the Philippe point about the satellite manufacturing part, which he highlighted as one of the key domains where there can be quite a significant impact from machine learning or artificial intelligence. So maybe you can comment on that, how you see that yourself at MDA.
Sure. Certainly from an advanced manufacturing perspective, artificial intelligence and robotics is certainly playing an increasing role. We're finding that as we transition, especially in terms of high volume manufacturing for larger constellation of low Earth observation satellites, we're increasingly using robotics-based manufacturing, robotics-based inspection, which includes a whole AI system behind that to be able to make that function in terms of collaborative groups of robots working with humans in the manufacturing process. So we're definitely seeing that in the space business. In terms of picking favorites, I don't know, I got to be careful here. I got like employees all across the country that are using AI in all different applications. I have to be careful about picking favorites. I think in terms of big impact, Earth observation would certainly have a large impact as we get more complex constellation of Earth observation satellites working in collaboration. The opportunities for the use of AI in coordinating Earth observation activity, in fusing and aggregating and extracting information out of the data sets that we're collecting and then disseminating that. There is very, very large number of applications for artificial intelligence to improve that process, and it will be critical to that process as the volumes increase and as the types of data extraction that we want to do get more and more complex. The more persistent our observation becomes, the more the change detection is going to be important, the more that having automated change detection to then drive ongoing analysis. I think all of that impact will greatly improve the efficacy of Earth observation. On the robotics side, however, though, it's going to be essential, like for us to go to further distances, for us to now operate next out by the moon with lower levels of communication, less frequent communication, the importance of having artificial intelligence-based robotics autonomy for lunar operations, and then that even further distance that Isabelle was talking about when we finally get out to Mars. Artificial intelligence is going to be essential just to be able to make those robotic systems operate. So I think in Earth observation, we'll see a tremendous improvement in our performance with AI. And I think in long distance exploration, AI is going to be essential to our ability to manage robotics at those long distances.
Yeah, no, for sure. The polling results clearly show the Earth observation is widely considered as the biggest impact, where they expect to see the biggest impact. But I think we already, Isabelle, before we'll talk with Joel and Philippe a bit more about Earth observation, but maybe about Isabelle in terms of the space exploration. So clearly over the weekend, there was another major milestone achieved by SpaceX. And again, as you mentioned as well, the next step to go on the moon, but at the end to go Mars, where the artificial intelligence is kind of a key requirement to achieve that goal. So, with this very ambitious goal, could you maybe show us a little bit your vision or view of how AI will be integrated, so to kind of build or achieve a settlement, or at least reaching the Mars milestone?
There are two areas that are very important, as Mike mentioned, the operations, so anything that concerns how the mission itself and how the astronauts will perform their various tasks without having ground support. If you watch the SpaceX launch, Demo 2 as well, and all the the process to reach a station, it took 19 hours. But along all that process, of course, it's a demonstration flight and it's necessary, but there was always ground support in real time there to tell the crew and to assist the crew in the various steps, either on board the station or in the Crew Dragon vehicle. So it won't happen like this when we go to Mars. There won't be that real-time interaction, and that's where AI is going to be very important on an operational perspective. But for healthcare, this is really one big issue. For human exploration, the heart of the challenge is the human, is to see people further from the Earth and to keep them healthy. What's interesting with space exploration is that we're really looking at bringing the benefits to Earth. The context of space exploration, of a crew far away, being self-reliant, is very similar to the circumstances of our remote Arctic, Northern, and Indigenous communities in Canada. We know that healthcare delivery is not necessarily at the same level as it is in big centers and big cities, for example. And for healthcare, we really see parallels, synergies, affinities between the needs of a crew on a deep space mission and remote communities here on Earth, especially in Canada. We also see a potential big impact on the healthcare system cost. So using AI really has potential to reduce the cost by monitoring health remotely for patients and just putting more attention to the patients that need it most, keeping people at home as well. So we see, what the situation with the COVID, keeping elders and aging people at home will be important. So AI and new technologies will enable that. So what we will do, what we will need for healthcare and deep space missions is very similar to what we need here on Earth. So when we speak about impact, really we see space exploration as a driver for innovation in this area, and that will benefit us here on Earth. That's really the approach we're taking, working with various partners in remote communities to learn about their context, to learn about what it is to explore, what it is to be remote, what it is to be self-reliant and self-reliant and have limited resources, and what can we learn from that and apply it to space to solve those problems together.
Yeah, very interesting that you highlight that these effects can trickle down into impacting terrestrial on Earth, the health situation, how we can improve that. So as our poll already, and I think we partly expected as well that EO was kind of being a key area of big impact area. So Joelle, I think turn it to you. So I will start the other poll that you basically also suggested us to do, and it's kind of another deep dive into the impact of AI in the Earth observation. So here basically the question is as follows. So outside of defense and intelligence, where do you expect the most growth in EO data and insight sales in the next 5 years? So I'll give the audience to vote, but meanwhile, maybe can you highlight or explain to us, does Skywatch as well serve defense and intelligence, or are you really focused on serving the commercials, let's say the commercial market?
Yeah, our target is the commercial market. So the defense market typically is, long sales cycles and large contracts, but also large sales forces that are involved in that. And for us, we really see the advantage of, 99% of application developers in the world don't use EO data, and there's a huge opportunity for them to use it. So, an example of a customer, a great example of one of our customers who's doing this is in the oil and gas pipeline monitoring business. So they built an application that helps oil and gas companies monitor their pipelines in Europe in this circumstance. And what they've done is they've built a change detection model using Sentinel-1 data, so free open data, and they've divided up a pipeline from their customers into 1 square kilometer areas. And they detect change with every collection cycle of Sentinel-1 over those areas. And when something pops, then they can fire a request to our API and request a satellite image of that area that's changed. And for context, the way this works now is, regulations require that imagery be captured from overhead in Europe. So helicopters fly over top of these pipelines every week or two, and it's very expensive. Many of these oil and gas pipeline companies have fleets of helicopters they purchased. And the pilot leans over, if he sees something that looks like, a bulldozer encroaching on a pipeline, and takes a picture, brings it back to their headquarters, and they decide if they send boots on the ground to go talk to them and tell them that they're maybe, they have to back off. But with using free Sentinel data to do the change detection and then a satellite imagery that mimics the pilot, leaning over it, the costs are actually reduced by about 75%. And so in this case, the change detection, you could probably debate whether that's AI or not. The next step, which is the interpretation of the high resolution image to determine what actually changed and should we take action, Today, it's still eyeballs, but there's a big opportunity in those kind of situations for additional automation. And in my mind, these are the pragmatic pieces where, you know, if you can lower somebody's costs on a regulatory activity by 75%, then it's a no-brainer, right? It's sort of like, would you build a data center now, or would you use a cloud service like Amazon or Microsoft? Of course, you would use a cloud service. You're up and running with a fraction of the cost and, you know, a fraction of the time. So those are the opportunities that we feel are really exciting, the ones where it's just a no-brainer because the cost is reduced so dramatically.
Interesting, a good example. So looking at a bit of the polling results here, we see quite a variety of responses. I think is probably pretty fair there too, but environment, agriculture and infrastructure, energy utilities are standing out in terms of percentage of the votes. Is it something you would concur, or you might have a slightly different view on that?
Yeah, it's one thing that's really interesting with the business is because it's, you know, our CEO compares Earth observation to GPS in a lot of cases, because when GPS started, there were so many different potential use cases that it was really difficult for people to kind of narrow down to one really killer use case. And Earth observation is very similar. The nature of how many opportunities there are, I think, you know, in a poll like this, you see that come out. There's just so many different places it can impact.
And in terms of the customer sets today, is there like one from the mix of different like sectors, industries, as one that it's, you know, kind of the early adopter from your services or from your experience?
Yeah, I mean, if you broadly group infrastructure, I think, you know, any infrastructure monitoring could be construction monitoring, could be like the oil and gas pipeline monitoring, but anything like that, certainly there is, especially when they're in remote locations, that's certainly seen strong interest.
Very good, very good. Maybe Philippe, so, you know, you've worked quite a bit on the Earth observation side. So is there a kind of, in terms of, let's say, the end user application, end user markets, where do you see the kind of the biggest impact?
Yes, thanks for the question. Isabelle mentioned a bunch of ways in which what we're doing in space for our health can transfer here. And I think for when it comes to Earth observation, or even in general, when it comes to machine learning, the opportunity that space has that can be transferred here, I believe, is the fact that in space, you're stuck with dealing with very little data. So if you look at machine learning and the history of machine learning in the recent years, there's been a lot of very impressive results. A lot of them in vision-related tasks, you know, understanding what's in an image, or even synthesizing new images from scratch has shown really good results. But what you don't always see is the amount of data that's required behind the scene to enable these great applications. Like typically you will have a lot, like millions of images that have to be labeled, that have to be processed in order for one of these applications to work. And we know that in real life, the situation is not always that clean. You don't always have that many data points in order to train a system. And this is nowhere as true as in space, where you just can't, you know, you can't send someone to take pictures with their iPhones and label them, right? This is not going to happen. So this is something we've been working on quite a bit at Element AI. It's our ability to build machine learning systems in low data regimes, which is a situation that's faced by many of our customers and many people out there. And there are ways to tackle that. You know, it's always a trade-off. There are always ways to, you know, maybe reduce accuracy a little bit, or to expand the scope. But to combine the low data that we have with other mechanisms like simulations, like something called domain transfer, where we find an adjacent domain and we transfer the learnings from there to the domain we want to apply the machine learning system on. And in space, there are tons of opportunities to do both domain transfer and simulation-based machine learning. And for us, this is a very exciting opportunity to, you know, tackle the problem where you know, it's as critical as it can be, and then to transfer these knowledge back to situations that happen on Earth all the time.
So maybe Isabelle, I think that's a pretty interesting development where I assume as well, where you're working on, there's very limited data, right? Limited data sets could be considered as one of the key bottlenecks for working in the space environment. On top of that, there's really little room for error as well, of course, when you're dealing with health of astronauts. So maybe elaborating a little bit more on the topic of bottlenecks, right? What do you consider kind of as the main bottlenecks for adapting AI in the space environment?
For health, at least, that's describe what you're describing, Nathan, is really the reality, is really the biggest challenge we face for AI. We have very few astronauts flying to space. We observe the important adverse effects of space flight on human health. For example, the loss of muscle mass, bones, loss of cardiovascular condition capacity. Those effects are very important, are very dramatic. They're reversible when after long exposure to microgravity, they're reversible, but they're very, very important. It can take up to a year to retrieve or to regain the bone loss after a long duration stay in space. And you see, when the astronauts come back, for example, when they land in Kazakhstan in the Soyuz capsule, they need help to get out of the capsule. They're very deconditioned and their balance system, their equilibrium system is affected and all that. So imagine a crew going to Mars, being exposed to microgravity for up to a year, and then having to do everything by themselves on the surface of Mars. Just think the astronauts come back in the Soyuz, how they feel, how much help they need. And then you have astronauts on Mars by themselves. So this is a huge challenge. And we observe the effects of spaceflight on humans. And yes, we have very few subjects to understand what's going on. We have limited also technologies or infrastructure in space to study health. So we do good research, we do great research, but with very limited capacity. So we're trying to improve that. But definitely for AI, because we have so few subjects, what you described, Philippe, having like a similar population experiencing similar effects is important. For example, the intense physiological conditioning that astronauts are subject to in space is very often compared to aging. Like arteries of astronauts can harden in 6 months as much as they would harden in an aging person over 10 to 20 years on Earth. And that happens in 6 months in space. So we see those dramatic effects, but we have very few subjects, and we try to find those links between what we observe in space and similar conditions on Earth. So that's where we need to push the capabilities. We need to push AI to help us apply it to healthcare in deep space. Yeah, so that's really a huge challenge that we have. And also the other challenge that we have is the limited resources on board. So we won't have all the service and all the data once we are on Mars. We won't have access to that. So we'll have to find a way to work remotely with AI as well in that situation.
Good points. Mike, maybe from your experience so far with adopting AI into manufacturing and other parts of the business, what do you consider as the major challenge or bottleneck so far when you want to implement that?
Yeah, so I agree with some of the challenges that have been said so far. Certainly the low data sets or the low opportunities to train. Often we're creating artificial intelligence for one environment, and there's only one of them in the world. And if you take a future space station, it's going to be assembled and operational. So you have to develop the AI-based control environments using simulation-based learning based on models of that environment, and then very carefully validate those in operations. I think that the validation and trust is a huge issue. I think that we have these very, very critical operating systems, satellites that are operational, and we want to be able to incrementally introduce artificial intelligence into the analysis that's coming back from satellites, often in parallel to the humans doing the same task, so that we can build up trust and then gradually gain confidence in that moving forward. If you look at the example of robotics, we've been working with the Canadian Space Agency and NASA, of course, over years to gradually build up trust as we've increasingly automated robotic operations. today now in the current International Space Station on Canadarm2, we would have now what we call supervised autonomy, whereby we're increasingly making upping the goal-based behavior that we're giving robotic systems, but robotic operators are still very much supervising that autonomy and having human in the loop to agree and release it into the next mode. Over time, that just continues to aggregate and aggregate over time until we'll get out 5-6 years from now and space stations by the moon with confidence to get there. So it's a very slow process to work through a low data environment, to then build up the knowledge in AI-based systems, and then very carefully and incrementally be able to test and validate those things moving forward. A last area, which I think has been mentioned in, would be the balance between home computing and edge computing. There's only so much compute power that we can put out on a satellite for onboard processing, or out in an operational system in a space station in the moon or to Mars. And so Isabelle mentioned that the balance between what we can compute at home versus the distribution of that compute out to the edge requires a continual advancement in pushing those boundaries and optimizing the AI environments and their processing to be able to work in those lower horsepower edge computing environments.
Yeah, that's interesting. Maybe Joe as well. So you already painted a little bit the picture of this process where everything is automated, right? So the capture of the data, or of the image, where in the world, as well the processing, and then up to the analytics, it can become predictive at one point. So where do you see within this kind of this full chain of process, where do you see the biggest bottleneck today to make it fully automated?
Yeah, I mean, well, so for us, really, it's focusing on these little pieces that we can try and provide clear value in and eliminate the humans in the loop. But I think kind of picking up on what Mike was saying, one of the other bottlenecks just in general in any AI project is there's this unknown about the payback, right? So you can invest 6 months and a team of people developing a model to try and predict something and apply judgment to it, defining AI, but it might fail. And you might never get past that human judgment and prediction level. And so that's difficult for a lot of companies too. It's not like you're laying a mile of track and how much that costs and how easy to do it is. Sometimes you're going into these situations, and I envy Phil because he's probably in lots of them, where you really don't know if you're going to be successful or not embarking on these projects. So to me, I think that's like at a macro level where some of the bottlenecks are, just as the industry transitioning to AI and predictive analytics, is just the investment that's required and not necessarily any kind of guaranteed payback. And we think you can mitigate that, or we think we can mitigate that by looking at these kind of smaller pieces, right? So whether it's cloud prediction, or whether a sensor creates an image that's got some problems with it, so that we can detect that ahead of time. Those little micro increments are for us the way that we're eliminating some of those bottlenecks, but certainly tons of other opportunities out there too.
Very good. Good. So before I turn to the audience questions, there's you can interrupt. Sure, go ahead.
Sorry, I just wanted to comment very quickly on what Mike said, because I think it's a very important aspect of the relationship between AI and space, right? This is the one thing that space has, like, more than anywhere else. We can build models that work 99% of the time, but in space, that 1% might mean like people die, right? So it's super critical to think about two things here. First is humans must be in the loop. And that's how we design all our systems. It's never, hey, we're going to replace humans entirely. It's always about, hey, can we help humans do the task they want to do? Can we assist them in what they're trying to achieve? And so this brings one of the big challenge, and something I would even call a myth about current machine learning, is that we've all often described current machine learning systems as black boxes. And they definitely started as such, in a sense that we put a lot of data there, and then we ask these boxes, please predict something. And it predicts something, and then we say, hey, okay, can we look at the internals of it? It's not like a software with if then else in there that you can like trace through and figure out what happened. It's really hard to figure this out. But we basically, like, at first we kind of stop there and say, oh, this is impossible to use with humans in the loop because humans can't understand what's going on. But the fact is, we can do a lot better than this. We can build a bunch of tools to help these models explain themselves. So this explainability track is something we've been working on quite a bit, with the desire to make sure that these tools can really assist humans, and humans can basically be better informed and better aware of the decisions they're making, and just basically be able to make a lot more of these decisions more intelligently. So that's one of the important aspects of AI in space. And that's an aspect that can transfer here, because we know a lot of people on the planet want a trustworthy relationship with the AI tools that they use. And in order to get there, we need to build these explainable systems, and we need to think of them from the beginning.
Very good. And it's, I think, also a nice kind of segue into this last polling question where, of course, the man of the hour, our poster child, Elon Musk, always provides some provocative quotes in terms of artificial intelligence. So this one is an example where artificial intelligence, as he mentioned, is the biggest fundamental risk to the existence of human civilization. So majority disagrees. Interesting, maybe Philippe first. I'm not sure you're aware with the quote itself, but I think you kind of alluded a little bit your thinking about it. But simple true or false? What do you feel there?
Yeah, I'm sure my PR department would be listening now. I mean, it's, technology is neutral. That's what I would say. It's up to us humans to make sure that we build the policy systems around it to make sure that that it evolves in the direction we care about. I don't buy the doomsday scenario, Terminator-like, that we're going, like someone in their basement is going to invent an AI that's going to rule us all. Not going there. What I do believe is that we need to take a good look at what we're building. This technology is novel. It's not, it's evolving very quickly. Let's make sure that it's always helping us be the society and the people we want to be.
Yeah, anyone else? I think we'll soon start with the audience questions, but I think, to give a bit of context as well, the quote was primarily referring to a request for, let's say, government oversight for regulation in terms of the AI environment. Is it something that you would see as well as a priority? Joelle or anyone else that want to comment on this particular?
I would say yes, definitely. I think what he says there's a risk. So we're not doomed. And I profoundly believe in human nature. I think the bright side will win. Of course, often the solutions of the past become the problems of the future with technology. That's the way it is, it evolves. And I think that, yes, the right frameworks, we need to think about those things. We need to think about the risks. We need to be much more ahead. Technology is really evolving fast. And until we shouldn't wait until something happens before we think about it. It's a little bit like with the COVID situation. Everybody says we aren't ready for that. So if there's something we can learn from the current situation is that we should be ready for AI before it happens and have the conversations and have the right regulatory frameworks and laws in this area. Definitely.
Yeah, and I'd agree with Phil on the transparency side of things. The difference between something that feels creepy and something that feels valuable is generally transparency. And if you think about it's maybe Google telling you the place where you were the most and giving you ads related to that can be creepy, it's unexpected. But if you have your Spotify playlist and Spotify is recommending songs to you, they're equally mining all your personal data, but it's valuable to you because it's expected. You're asking them to do that. So with AI, I think it's these two diametric areas that the transparency really lifts that creepiness into something of value if it's expected and you have control over it. So I think it's going to be really important.
Okay, good. Let me turn it to the audience questions. We're about 10 minutes left. So let me show the first one. The space industry has traditionally been more reluctant than most to adopting new technologies for flight system, favoring products and approaches with flight heritage and established reliability. So how do you build confidence in AI for critical flight applications? So maybe Mike, can I give that question first to you?
How do you build critical competence? I think that it's like what we were just talking about a minute ago about regulations. We look at I think the engineering process takes care of that. There was a great picture on social media over the weekend with the launch of the Apollo cockpit versus a shuttle cockpit versus a current SpaceX Dragon cockpit, going from analog dashboard to a digital dashboard to a glass cockpit. And we go through these evolutions that seem scary as we go from one step to the next, and now we'll introduce more AI-based processing into our systems and solutions, and go through our typical engineering processes to be able to integrate those into designs and go through the appropriate verification and validation procedures to be able to prove those and sign off on them and build trust in the system through a full and proper range of test scenarios like we always do. It's just the next evolution of using technology to improve efficiency in operations of satellites for Earth observation, or improving operations of robotics or sensors for space exploration.
Yeah, maybe Philippe, anything to add to that in particular? I know you're not building necessarily flight systems, but
totally with Mike on that one. This is this is a technology like any previous technology. I think space has demonstrated a great ability to learn how to build trust for new technologies. Let's apply the process here. Let's make sure we see the great potential it can have. It kind of takes a different mindset, because you cannot necessarily go back to the first principles and understand everything about the machine in the same way that typical engineering might be able to. But at the same time, we trust human brains out there. We trust people. We need to be able to have a process that allows us to validate that this technology can be trustworthy, and we need to start on it and explore it.
Okay, good. Anyone else want to answer? Otherwise, I go to the next question. Just going on. So a lot of satellite data is often validated with data from the ground. This is often considered essential rather than optional add-on. So this question is for you, Joel. Are there any Skywatch solutions to cut this add-on cost?
Yeah, so I mean, I guess depending on the type of data and the ground truth that you need, certainly there's lots of different examples of that. But I mean, I guess just sort of an extension of that is it's the ultimate product that Earth observation is trying to generate is not actually an image, right? The actual product it's trying to generate is data that could feed into an autonomous tractor and optimize the fertilizer spread for a large farm or something like that. So there will be a lot of heterogeneous data required, whether it's from IoT, whether it's other ground truth data, et cetera. But that's really where we see all this going is it's not going to be imagery, in 5 years. It's going to be just the analysis that comes out of the imagery today that generally is performed by humans and increasingly by models. But it's that mix, and it becomes really a data engineering problem, which is what I think is really exciting. It's this combination of data from different sources, and this is just one stream. It's going to be a hugely valuable stream, but how that compares and goes into this massive amount of IoT data that's going to be generated and existing other ground truth data, that's going to be another big data engineering challenge to solve. So not something we're tackling now. We're sticking with the problem of just aggregating Earth observation data and normalizing that for the 99% of people that haven't used it before. But certainly lots of other big challenges that come out of that question.
All right, good. I'm getting a lot of good questions now. So let me take another one. Concerning deep space exploration, is AI a good tool for vehicle guidance systems in space, just like self-driving car? Isabelle, maybe you want to take this one on.
Well, yes, I can take on this one, but I think I'll pass it to Mike as well, because I can definitely, yes, the first demo, the first SpaceX demo that happened during David Saint-Jacques mission. Actually, David Saint-Jacques, our Canadian astronaut, was the first person to enter the capsule in space once it reached after it docked to the International Space Station. So that one was with all control from the Earth. So there was again a lot of involvement from the ground, but at the same time there was nobody on board. So it was all automated. So it's possible to automate, and it will be necessary to automate lots of those operations in space. If, you know, if only it can allow us also to use humans where they can be most useful. Because if something can be taken care of with AI or automation, then it frees time for humans to use their minds and their intuition and their creativity and their explorers' mind to solve more challenging problems. So definitely, but for robotics, then Mike's and MDA is working on this for rovers, for example. So how do you navigate autonomously in an unstructured environment, like with self-driving cars?
Good, yes, Mike, and as well have another question. So we're going to hit two questions with that, but please go ahead. So the other question was also about if you can give us examples of how AI might be used on a Mars surface mission. So related to both questions, maybe you can give us some.
Yeah, so I can just agree and say yes to there's roles for AI in the automation, in addition to the decision support, for navigation for sure, and for flight operations, no doubt. For rover operations, whether it's on the moon or for Mars, we just talked about autonomous navigation on those surfaces, and to be able to use vision-based processing of the environment or other sensors to be able to feed into the navigation planning and navigation operation systems for sure. For robotic operations, to be able to have higher level abstract goals to be able to give to a rover system and or its robotic systems, to be able to have short burst, high level goal commands that can be transmitted over those low bandwidth, long lag communication links, and then have the intelligence on board to take that high level goal and work it through its solution. We will definitely see opportunities for those.
Good. Okay, a final question that I can take over here is for Phil. If you could please elaborate more on AI opportunities in manufacturing.
Yeah, there are so many, but let me maybe bring back the challenge of understanding, making decisions in unexpected situations, which is something that you very often have to do in manufacturing. So what we realize is that there's a lot of tacit knowledge in manufacturing, and that knowledge is embedded in a bunch of different systems or different ways. So the ability to understand unstructured information, natural language information, is something that AI gives us. And so we truly believe that just being able to organize that kind of information, to query it, will allow manufacturing process within a manufacturer, but also within groups of manufacturers, to make much better decision, much more informed decision more quickly about what needs to be done. So honestly, in many ways, the future of AI is going to be the future of extracting knowledge from sources of semi-structured or unstructured information and making that knowledge accessible to people so they can make better decisions. In the case of manufacturing, it's definitely a place where this will help.
Very good. I think we're at the end of the hour. I would like to thank you all, my panelists, for this discussion. I think we learned a great deal about some of the real case examples of AI applied in space, some of the opportunities for us in the future, and as well some of the bottlenecks and the challenges that we have to encounter getting there. But it was a great discussion. To thank you very much for your time today, and we'll keep continuing discussion about this great topic in the coming months. So thank you all for joining today. Hope you enjoyed it, and wish you a good day for the rest of the day wherever you are. So have a good day. Bye-bye.
Bye-bye.